All right, this is lesson 4.5.1. Now we get to start taking the derivative of natural log. So here we have an equation, y equals natural log of x. One of the things we did in the last lesson, 4.4, if you remember, was rearranging from logarithmic form into exponential form. So if we used a base e on both sides, this base e would cancel the natural log, which would lead to this equation, e to the y is equal to x. Because what we're trying to get at here, let me explain what we're doing here, is what is dy dx. Remember, dy dx is the derivative. So if y equals natural log of x, what does dy dx equal? To get to dy dx, we're going to go into exponential form for a moment. So from this form to this form, okay, now if we differentiate, but with respect to x, if we differentiate with respect to x, remember the derivative of e to the y is e to the y. This is the chain rule. So here's the derivative of the outside part. Now we multiply it by the derivative of the inside part, and the derivative of y with respect to x is dy dx. And then the derivative of x is 1. So this equation right here is the derivative of this. And remember, this is numerically equivalent to this. So now if I want to get dy dx by itself, I'm going to divide by e to the y on both sides. So that's what I've done here. I've isolated dy dx by dividing by e to the y. Now I'm going to make a replacement. E to the y is equal to x. So I replace e to the y with x, and we have this here, that dy dx is equal to 1 over x. So the connection we're making is that if y equals the natural log of x, then dy dx equals 1 over x. And that's the definition of the derivative of the natural log of x. So the derivative of natural log with respect to x is 1 over x. Now, like with e to the x, this expression inside the natural log may not be just x. It could be 5x or 10x squared or something. So now we can do this same thing with the chain rule. The derivative of the natural log of u is 1 over u. This is the chain rule. Now we need to multiply that by the derivative of u with respect to x, which is du over dx. So this is what we're going to work with, these two definitions, when we're doing derivatives of natural log. So a couple of examples. So the derivative with respect to x of natural log of 4x. So think of this as natural log of u, where u is equal to 4x. So according to this definition, the derivative of natural log of u is 1 over u. So it's going to be 1 over 4x. Now we need to multiply it by the derivative of u, or the derivative of this expression inside the logarithm. So the derivative of 4x is 4. 4's are going to cancel. So it's 1 over x. Okay, part B. Again, if we think about this expression as u, the natural log of u, then the derivative of natural log of u is just 1 over u. So it's 1 over 5x squared. This is chain rule. So we have the derivative of the outside part. The derivative of the outside part is just what's the derivative of the natural log of something. And it's always 1 over that same something. Then you multiply it by the derivative of the inside part. Now the inside part is 5x squared, and the derivative of 5x squared is 10x. So this is 10x over 5x squared. 10 divided by 5 is 2. And then x divided by x squared gives us an x in the denominator. So the derivative is 2 divided by x. Now, an alternate way of thinking about part B, this is an alternate way, would be to use the technique that we talked about in section 4.4, expanding logarithms. So if we expanded this, it would be natural log of 5 plus natural log of x squared. And then we could move this exponent down in front, so that would be natural log 5 plus 2 times the natural log of x. Now if we differentiated with respect to x, natural log of 5, it's kind of hard sometimes for students to grasp this initially, but natural log of 5 is just a constant. This is just like a 2 or a 15. Natural log of 5 is a constant value with no variable, and the derivative of a constant is 0. So the derivative of this is 0. 2 is a coefficient, so it doesn't really play a part in the differentiation process. So all we're differentiating with respect to x, really using any kind of rule, is the natural log of x, and the derivative of natural log of x is 1 over x. So the derivative of this is 0. It's 2 times the derivative of this, which is 1 over x. So we have 2 times 1 over x, which is 2 over x. So that's an alternative way of thinking of that. Okay, now part C, we're going to have to use a product rule. We have the product of two functions, f times g. So the product rule, remember, is f prime g plus g prime f. So the derivative of 3x is 3, so that's f prime times g plus g prime. Now, if g is natural log of x, then g prime is the derivative of natural log, which is 1 over x. So this is f prime times g plus, this, remember, is g prime. Now we need to multiply it by f. Okay. Now combining some like terms, 3 times the natural log of x plus, here the x and this x are going to simplify, so it's just 3 times 1, which is 3. And then if you factor out a common term, it's 3 times the natural log of x plus 1. All right, with part D, one of the things to remember is natural logs, any logarithm really, and radicals, they don't mix well. So I'm going to rearrange this into natural log of 1 minus 2x to the 1/5 power. And this is what we're going to differentiate. Okay. Before we do that, actually, excuse me, I'm going to take this and move it down in front using that power property we talked about in section 4.4. So this is the derivative with respect to x of 1/5 times the natural log of 1 minus 2x. So this 1/5 is just a coefficient, so it doesn't really play a part in the differentiation process. We need to differentiate natural log of 1 over 2x, or 1 minus 2x. Now, again, remember, the derivative of natural log of something is 1 over that something. So this is going to be 1/5, and then it's 1 over 1 minus 2x. That's the derivative of the outside part, natural log. Now we need to do the chain rule part and multiply this by the derivative of the inside part, 1 minus 2x. And the derivative of 1 minus 2x is negative 2. So when we multiply it all together, we're going to have a negative 2 in the numerator. 5 times 1 minus 2x in the denominator. Okay. Part E, we're going to do a similar thing here. I'm going to rearrange that natural log expression. So natural log, raise it to the power of 1/2 rather than the square root. And then we can move this 1/2 down in front. Okay, now this one's going to have a few pieces here. So again, the 1/2 as a coefficient just stays 1/2 as a coefficient in the differentiation process. Now we have the derivative of natural log of something. So again, the derivative of natural log of something is 1 over that something. Now we need to multiply that by the derivative of this inside part. Now, unfortunately, this is a quotient rule, so we need to multiply this by a derivative that's a quotient rule. So, low d high minus high d low over low squared. Alright, here's where it's going to get real fun. This expression, 1 divided by x plus 1 divided by x minus 1, really just means we invert this fraction. So, 1/2 times x minus 1 over x plus 1. And then here we have x minus 1 minus x plus 1. So I'll write that a little more clearly. X minus 1 minus x. And if you distribute this minus sign, you're going to get another minus 1. So x's cancel, and we have negative 2 over x minus 1 squared. So multiplying everything together, negative 2 times x minus 1 over 2 times x plus 1 over x minus 1 squared. The 2's can cancel. So we have negative x minus 1 over x plus 1 times x minus 1 squared. So 4.5.2, we've been doing derivatives of base e logarithms and exponentials, so now we're going to look at exponential expressions that have a different base, like base 2 or base 5. So this question we need to think about: what is the derivative of 2 to the power of x? Because remember the rule, the derivative of e to the power of x is just e to the x. But it's not the same when it's 2 to the x or anything else besides e to the x.
Okay, come here.
So let's go through a little exercise here.
We have to not be boring or else he's going to leave me alone.
2 to the x.
Wait, hold up.
If I have a base e and a natural log as an exponent, those just cancel out. So in a numerical sense, 2 to the x and e to the natural log of 2 to the x are numerically equivalent. Because again, e to the natural log would just cancel out. We want to have a base e here because the derivative rules that we know of involve base e. So rather than having a base 2, I converted this to have a base e. In order to keep it numerically equivalent, I had to also have a natural log to cancel that base e. Okay, now if we use the power rule, this exponent can move down in front of the natural log. So it's x times natural log of 2. But instead of putting the x in the front, I'm going to move it to the back like this. So it's e to the natural log of 2 multiplied by x. Okay, and this is what we're going to differentiate. And again, I know this looks completely different, but this is exactly the same thing as this, just in a different form. So why differentiate this? Again, because it has a base e. So what's the derivative of e to the natural log of 2 times x? Well, remember the rule, the derivative of e to some power, the derivative of that is e to that power multiplied by the derivative of this power. Now, the derivative of natural log of 2 times x, that sometimes confuses students. So if we consider this over here, natural log of 2 times x. What's the derivative of that? Well, what's the derivative? Let me ask another question. What's the derivative of 5x? Or what's the derivative of 10x? These are easy. We know these. It's 5 and 10. Why? Well, 5 is just a coefficient. 5 times x. So the derivative of 5x is 5. The derivative of 10x is 10. 10 is just a coefficient. Natural log of 2 is just a coefficient. It's a constant value, just like 5 or just like 10. Natural log of 2 has a constant value. It's just a coefficient. It's no different. I know it looks much different, but it's no different than 5x or 10x. So what's the derivative of natural log of 2 times x? It's the natural log of 2. Okay? So, again, here, the derivative of e to the natural log of 2x, 2 times x rather, is e to the natural log of 2 times x multiplied by the derivative of this, which is natural log of 2. So long story short, this now we're going to recancel. So e to the natural log, I'm going to cancel it out. And remember, this x was originally an exponent of 2. So if I cancel out e to the natural log, move the x back up as an exponent, I get this again, 2 to the x times natural log of 2. So what you need to connect here is the derivative of 2x is equal to 2x times the natural log of 2. Okay, now that was a long explanation for the definition here. The derivative of any base to the power of x is that power is a to that power multiplied by the natural log of a. This applies as a chain rule. So if the exponent is anything other than x, like 2x or x squared, a similar rule applies. The derivative of a to the u is a to the u. And then we do the derivative of u, that's the chain rule, du dx, multiplied by the natural log of a. This is going to be best if you memorize it rather than trying to remember this, how this formula came to be. So this is what we're going to be working with to do derivatives of exponentials with bases other than e. Now, what about logarithms that have a different base? So log base 2 rather than natural log. So one of the things we learned about Math 1050 is called the change of base formula. So the log base 2 of x is equal to the natural log of x divided by natural log of 2. Rather than dividing by natural log of 2, you can move that in front as a coefficient. 1 divided by natural log of 2 multiplied by the natural log of x. And this is what we're going to differentiate. So instead of differentiating log base 2 of x, we're going to differentiate 1 over natural log of 2 multiplied by natural log of x. Now this, again, it looks complicated, but it's just a coefficient. 1 divided by natural log of 2 is just a coefficient like 10 or 1/2. So it stays constant when we differentiate. So 1 over natural log of 2 stays 1 over natural log of 2. We really just need to consider then what's the derivative of natural log of x, and that's 1 over x. Okay. So what you need to, so what we're correlating here is the derivative of log base 2 of x is equal to this right here. 1 over natural log of 2 times 1 over x. So again, to generalize this, if we have the log base b of x and we're differentiating, we turn it into a natural log. 1 over the natural log of the base of the logarithm multiplied by 1 over x. Or if the expression inside the logarithm is anything other than x, then we can do a chain rule. So the derivative of log base b of u is 1 over the natural log of b, b is the base of that logarithm, times 1 over u, and now we do the chain rule, the derivative of u with respect to x. Okay, I know there was a lot of explaining, but we're going to have some examples here. So find dy dx will be part A.
Watch her take. Oh my gosh. Ours one?
So dy dx. So this right here, we can think about this as a to the power of u. So remember the rule, the derivative with respect to x of a to the power of u equals natural log of a times a to the u times du dx. So a is the base of the exponential, in this case 7. So it's natural log 7 times a to the u, which is a, sorry, not a, 7 times x to the fifth.
What?
And we multiply this by du dx, or the derivative of u. This is u, the inside part, or the exponent. So the derivative of u
Look, it's this girl that like defines her outfit.
is 5x to the fourth. And that's about as far as we can simplify it.
Guys, she got sent. Maya. She got sent like 10 prom dresses from Windsor. Yeah.
Okay.
For free. And she's renting them out.
Part B.
Why do I know that's illegal?
So dy dx. Here, we're going to consider the rule, the derivative with respect to x of log base b of u equals 1 over natural log of b, 1 over u
I was saying
times du
the lines
dx. Then b is the base of the logarithm, in this case 6. U is the expression inside the logarithm. And then du dx is just u prime, it's the derivative of u. So here we go. 1 over the natural log of b, in this case the natural log of b, that's the base, 6, so 1 over natural log of 6.
guys. No.
Has 1 over u. Now we need to multiply this by u prime, or du dx, so the derivative of the inside part here, 6x squared minus 10x. Now simplifying here, 1 times 1 times 6x squared minus 10x means that the numerator is just 6x squared minus 10x. The denominator is the product of these two terms, natural log of 6 times 2x cubed minus 5x squared. Okay, last learning target, 4.5.3. We're going to do implicit differentiation with natural logs. Remember, implicit differentiation is just chain rule. So if we differentiate this with respect to x, we differentiate each term at a time. So the derivative of 3x squared is 6x. The derivative of 4 times the natural log of y. 4 is the coefficient, so it stays a coefficient. Now, the derivative of natural log of something, remember, is 1 over that something multiplied by the derivative of that something, which is the derivative of y, dy dx. Now the derivative of 4y is 4 dy dx.
Shut up, do not ruin it.
And then the derivative of 6 is 0. Okay, now we need to get dy dx by itself, so I'm going to move the 6x to the other side by subtracting. Now both of these terms have a dy dx. So I'm going to factor that out. Okay, now unfortunately here we need to combine this into one term because we have fraction embedded in here. And if we were to divide this term underneath here, we'd have a fraction inside of a fraction. It's no good. So combining these into one term is not as hard as it sounds. This is really just 4 over 1. So multiply it by y over y. Now it becomes
So do you want to rent it or not?
4 plus 4y
On your hands.
divided by y. And the reason we went through this is we need to divide this term
No,
over here.
some of the things in here,
So here's what it's going to look like.
give me the egg. Not like just some things that he says to her that he's like. And I'm like, but the rest of the time.
Now, when you're dividing by a fraction, this divided by a fraction, remember dividing by a fraction is just the same thing as multiplying by the reciprocal of this fraction. So
4 o'clock, 5 o'clock, 6 o'clock, 7 o'clock, 10 o'clock.
I'm going to multiply by the reciprocal.
I know it's 4 hours. A whole hour? What are we supposed to do?
And then multiply those two expressions together.
Sleep. How? I don't know.